Okay, so what we're going to talk now about is the remainder theorem. Okay, so what we're going to look at is how we can use a theorem to help solve and evaluate functions. Okay, so the remainder theorem says this. It says if the polynomial f of x is divided by x minus k, then the remainder is going to be equal to the function evaluated at k. Okay? So that means if I wanted to find the remainder, if I wanted to find, hey, what's the value of, so if I wanted to find the value of f of negative 3, then what I could do is I could use synthetic division, find the remainder using negative 3 as k, and whatever the remainder is, that's going to be the answer. So instead of just plugging in negative 3 into the function and solving it that way, I could use synthetic division to find the remainder given this k value, right? So let's say this is k, and we could solve this by using the remainder theorem and synthetic division. Okay, so now, why does this work? Here's the thing. We already showed in the last video that any function can be written as a complex number, right? Where k is a complex number and r, that we can write any function with a complex number, given a complex number, and an r value can be written uniquely as this, okay? And this also holds for all complex numbers. This has to hold true for all complex numbers, including all complex numbers of x, I should say. Let me clarify that. So this relationship holds for all complex numbers x. So I should be able to plug in any complex number, and this will have a solution. Also, for the complex number k. So I can put in k into this thing, and I get a solution, which proves the remainder theorem. Because then what I can do is I can divide any value of x minus k, and the value of that function is going to be the remainder. Okay? And so let's do an example.